Welcome to Jackal DIY and Tech. I have a simple game that is meant to be used in exhibitions and other events. It's a basic timer made in Unity and can be used on Android devices. This is just a prototype. I do have a nice looking version of this, and the goal of the game is to stop the timer at a full second, so 00 at the end. This is all good and nice, it's working, but I want something a little bit more physical, and that is where a button comes in, like this one. It has two contacts, so it's a normal button, and it's used in arcade style games. So this, how I've connected it to the phone, is with the Pro Micro Atmega 32U4. It's a little bit of a waste to use just one pin for the button, so what I decided to do is to also use a bunch of LEDs. I will see how this works, but I can use 16 of them and make different kinds of animations, and the animations can be basically controlled with this button. So you press the button long enough and the animation will change. And I may also use another button. This one has a latching mechanism. What I can do with this one is to maybe reverse the direction of the animations, or maybe just disable them. And when disabled, the animation will only play once the user presses a button. Otherwise, when this button is turned on, the animations can be continuous. Now lastly, where will I put all of this? At least that is my intention, is to use this dead water pump. I think the size is good. It has two screws, so I have no idea what I'll do with these. Maybe grind them down. The middle opening, this is what I intend to cut out or drill out for this button. This hole is just big enough for this button to go in. I just need to make it deeper. As for the LEDs, as you can see, this is quite thick, so the LEDs should go right inside where the pump was. So all of that will go out, what you see, the white stuff. So the LEDs could be below that. Now I just don't know how the LEDs will light up. This obviously will need to be polished to make it milky kind of looking, like this is, because currently from the top it is quite clear. And for anyone interested, this pump is from Sys Cooling and the model is SCP67A. Probably not visible on the camera at such an angle. Now what's wrong with this pump? Well, it's not working obviously. It got a little bit hot and I do see some molten plastic here. Maybe this is an issue. I will have to open it, see what actually went wrong with it, and how I can actually then put all of the components inside, and hopefully the acrylic will not blow up on me while cutting it. Now let me just apologize because I took most of the fun away from you. Well, what I've done is taken this box, taken the button out, taken the PCB out, so let me move this away. I've then taken the big acrylic piece, which was most of the fun that I've taken away from you, by drilling this big hole, and I also depthened this hole to fit this small button. As for the big button, it will be this one. I then also sand down a piece of aluminum L profile to make this circular thingy so it is flush, and I also sanded down the acrylic so it has kind of a milky look to it, which would be very important when it comes to the LEDs. I did consider sanding these down. I took one out, sanded the inside of it, and found out that it's actually copper or some alloy of it, so it does not have a shiny aluminum or metal feel to it, like the top, so that is why I will leave it as is. The next thing that I've done is on the inside. I have taken out the pump, used ChatGPT to make this cutout or this shape, which fits nicely inside, and all of these holes, I have 16 of them, this would represent an LED. These kind of LEDs. Now this would work. I do have enough LEDs and also enough pins. On this, what is it? Atmega 32U4 PCB, but I then decided to use an LED strip, which would allow me to address each individual LED. I could also do this with these specific LEDs, but where is the fun in that if you can only have one color, as opposed if you take a strip like this one and have basically any color that you want. And also the animations will most likely be a lot simpler to do using this than using each individual LED connected to individual pins. Now I still have a couple of things to do. I will take you on a bit of a ride and show you how I will tackle the bottom part, which is this. So basically I have here a PCB, copper on the base. I want it to be in this kind of a position, so this will fit inside or on top of it. It will go all the way to the bottom. I will have a cutout for the USB-C, and I also want this PCB to somehow fit between these openings so that it won't move when you unplug and plug the cable in. That is why I made this shape, so it fits in. And now I have to just take these markings to this PCB, cut the PCB out, put it in, hopefully it will fit snugly. I will still have to make some cuts on the bottom section so that the whole PCB can fit in, or I could just cut it in the shape as I have marked here. So maybe that is what I'll do. It might be a bit easier than cutting all of this out. And then lastly, because this strip is a little bit wider, so it does not fit inside this opening, it is sticking out, not by a lot, but it is sticking out from this section, maybe 2 millimeters. But that is why I cannot use these LEDs, as I have to remove this section. So I will also cut out this section so the strip can simply go down. And one more thing, maybe I'll also have to cut the bottom part of this section so that this PCB can fit inside. And I think that will be all when it comes to the mechanical part. Then we'll just have some fun making the connections, so connecting these two buttons to the Atmega chip and programming the LEDs to make some cool looking effects. So I have everything that I need. I have this piece, these two pieces, also the PCB to test how it will fit. And how I will do the cuts is with this little Parkside Dremel type of tool, which was a cheap tool, but it does a good job. So previously I cut the plastic with this wheel. That's why it's all black on the outside, and hopefully it will still manage to cut the PCB. So I managed to do the fit. I don't know if you can see it. I'll show it close up inside. So I have a cutout for the USB-C, and I had to make a cutout all the way down here along this section to fit the whole PCB in. And basically it will go in from the top, just slide in like so. But I'll see what I'll do with actually soldering this down to the bottom PCB. Now the last thing that I need to do is to make a cutout along this section, just so this PCB, the new one, the top one, will actually fit in. When it comes to this tool, it's okay, but it has one issue, at least the unit that I have, and that is the wobble. So I will see if I can fix it, and if I can, it will be in a separate video about this cheap tool. So let's see, does it fit? It does nicely. The whole PCB is in, also the bottom one, and it doesn't stick out, so this will hold nicely. One more thing that I have to do is now cut out this section, and to do that I don't think I can do that nicely with this attachment, so I think I'll just have to take a drill again, drill a bunch of holes and just do it that way. And we're back inside. Everything is almost up and running. The only thing that I have to do is use some hot glue to put this thing together. So I will hot glue the small button, the big button from the bottom, and I also need to glue the PCB into place so that it doesn't move. I have also used some double-sided tape and left one side still intact, and that is mostly because I do not want the LEDs to show up. So the red LED indicating the power and the blue LED anytime you press a button. So this is pretty much rock solid. So for the connections I will still use some hot glue on the pins so they don't pull out accidentally, and I will hot glue in the current refit. Oh, and one important thing, it's with the LEDs. If you remember previously, this is the LED strip. I just went and cut out the last section of the LEDs, and the last section already had some solder applied to it, so I simply soldered the connections on the end, which is incorrect, because you do have an arrow pointing downwards, which means that, at least to my understanding, the 5 volts and ground could potentially be soldered in the back, but the input, meaning the signal, the middle pin, has to be wired in the front. The way I've done it though is I've just moved all of the wires to the front, and now the LEDs work. Previously it did not, nothing showed up. I connected this strip and this one lit up perfectly. So then I immediately went over the strip and saw the actual markings. So I think the glue is dry enough for me to close this up. Screw this in with the 4 screws. As you can see, I did not use this silicone seal because I actually had to also increase the hole. The hole in the center of this plastic was not actually in the center, it was offset because the pump was also offset a bit. So that's why I had to increase the hole, and it means I cannot use this. In any case, let me connect this up. I have already written all of the code that I want to use. And this is what the button does. So I have a breathing mode. I can press a button. It spins 8 times. And then one of the colors will be randomly selected to continue with the idle animation. So I have the pinkish one, the yellow one, and also a bluish one. And then I also have different idle animation. So this one is breathing. This one goes from this side all the way to this one and back. This one is random and one of them was skipped, and that's because this is a latching button, so I would actually have to push it all the way in, which is not ideal. But if I press it lightly, then I can also change it. The second animation starts at the top and goes round like so, and it changes between the colors that I have input in my list. And all of this works if I press this button. Animations will continue with the idle animation that was selected. Now I can make a lot more animations and also specify different colors if I want to have them to be used in the idle animations. Now, as you can see, the code, it is quite big, 1400 lines, but this is actually not the whole code. I have a bunch of code that was used just for testing, and this is the section that I use. It's uncommented. It also has some serial monitor display, and this is for testing as well. So if I press a button, it mentions which animation was triggered, and if I press the small one, it also mentions which mode is being enabled. So I have 4 modes in total, but I can add to this. When it comes to the button press, as you can see during the animation, it's pressing the space a bunch of times, which is not the case while in game, which this big button is the whole point of, to work inside. Now this is a simple game, a little bit more complex than just stopping a timer, but it works in a similar fashion. We have a fuse characteristic and we have to stop a ball at the correct time. So when I'll press the button, I will not be able to press it again, and the spinning animation kind of matches up with the button, not at the start, but it does match it at the end. So it matches at the end. So now I can press the button again. And I also added 2 videos just for placeholder and to have a little bit more fun. Awesome. And then if you miss completely, the roof is on fire, which this meme represents, but as I said, it's a placeholder.
I told you to be quick, and this is why. You waited too long. Now it's gone up in flames. Nice! You saved the day with that perfect trigger. Excellent. I couldn't have timed it better myself. Great. Now we're going to be here all day.
That's it for this video, and I'll see you in the next one.